A confidence interval is the range of values that is likely to contain a parameter with a certain level of confidence. This is the formula for the 1 minus alpha confidence interval for the difference in population means, mu1 minus mu2. Where for samples 1 and 2, x bar 1 minus x bar 2 is the difference in sample means, t star is the absolute value of the critical values that give 1 minus alpha in the middle of the t distribution with n1 plus n2 minus 2 degrees of freedom, and the last term is the standard error. SP is the pooled standard deviation, and n1 and n2 are the sample sizes for samples 1 and 2 respectively. The margin of error is the critical value times the standard error. This is the formula for SP, where S1 squared and S2 squared are the variance for samples 1 and 2 respectively. Let's see how to construct a confidence interval. Suppose you want to estimate the average number of ravens in 2 countries, so you counted the number of ravens at 10 random locations in each country. You can summarize the data by calculating the sample size, mean, and standard deviation. You can define the difference as the mean of sample 1 minus the mean of sample 2. You could have defined the difference as the other way around, it just changes your interpretation. You want to estimate the 95% confidence interval for the difference in the average number of ravens across all locations between the countries. Step 1. Find the critical value. You want to find the critical values that give a probability of 0.95 in the middle of the t distribution with n1 plus n2 minus 2 degrees of freedom. The total probability under the curve is 1. So this is equivalent to a significance level of 1 minus 0.95, so 0.05, in total across the 2 tails of the distribution. The 0.05 is split equally between the 2 tails, so the probability is 0.025 in each tail. The degrees of freedom is the sample 1 size plus sample 2 size minus 2. You can use the t-inverse function to find the critical value that gives a probability of 0.025 in the lower tail. For the probability parameter, select the probability for a tail. For the degree freedom parameter, select the degrees of freedom. Encompass the t-inverse function within the ABS function to get the absolute value. The output tells you that the absolute value of the critical value is 2.1. Step 2. Calculate the pooled standard deviation. This is how you can enter the formula. Step 3. Calculate the standard error. This is how you can enter the formula. Step 4. Calculate the margin of error. The margin of error is the critical value times the standard error. Step 5. Construct the confidence interval. The lower limit is the sample mean, minus the margin of error. The upper limit is the sample mean, plus the margin of error. The output tells you that the 95% confidence interval is minus 2.18 to 0.58. For more lessons on statistics, visit alphas&betas.org.